Hello everyone, welcome back. I am Vijay and today I am here to first look into the project to divide it into tasks and then I shall guide you to complete all the tasks. We will complete the task as such with two approaches. One is to use command line interface, another is to create nodes in which we shall learn the coding part. So in today's session, we shall focus only on the command terminals. That is CLI tools, command line interface tools. In ROS 2, we build a system by creating nodes that communicate through topics, make requests via services, and carry out long tasks using actions. So collectively, we call these communication method, that is topics, services, and action, as interfaces. We can control these nodes, one or many, with parameters, and if needed, we can record everything using bags. All of this is organized within package to keep the work structured. We will quickly revise the command line tools that we have used in our last session. We started with package list and then we selected a package and then find the executable of the package using ROS2 package executable. Then we use the ROS2 run command to start any executable. So Turrtlesim executable node we have started. We have used node list to see the list of nodes available. Then followed by the node info. To go into more detail, we run another, you can say, executable turtle tally of key. Then node info will give you the information about that node. We also used the echo command for subscribing to any topic and the topic will only subscribe once the node is publishing. So we use tally of key to publish on that topic and then it's subscribing. We used service call to call a service and for that we use clear service of Turrtlesim node. We use spawn service as well to spawn the turtle. Two different turtle we spawned and then finally we check the interface using interface show command. So these were all that we discussed. So now let us come to the project part. So this project can be divided into three different parts. Tracing frame. The coordinates are given. Initially the turtle takes 5.5 and 5.5. Then the first column of the frame, then this member and this member. Then seat and handle are part of same group, but we can trace them separately. And then the wheels, the coordinates are all given. So this is how we can trace them. So we can be starting from here to here to here to here, and then the handle and this rectangle and then the two circle. The important thing to note is the change of the color, and when we move turtle from one position to another position, whether we want to trace that or we do not want to trace that. So these are the two important things. And then tracing a wheel is also very important aspect of this particular project. So we will be using only command line tools for tracing this particular bicycle. So now let us open the terminal with the Turrtlesim in one of the window, and in another terminal let us try to move this using teleport absolute service, so that for that we can see how many services are there using ROS2 service list command. So if I use this, we find that tally of turtle absolute is one of the service that we can use, and this service uses what type of interface, that is for that we can use minus t or dash t. So this teleport absolute uses this teleport absolute service. So we can check the interface of this service using ROS2 interface show and then the type of the service. So let us paste it and then check. So we get the float 32x, float 32y and float theta. So there is no response, so that is why it is not there after 3 dash. It's only the request it is shown. I can make this service call, ROS2 service call, the absolute position 3.526. So if I press enter, this turtle will move from this point to this point. But we do not want any trace when we move from this point to this point, and that is why we need another service, set pen service, to make this pen off. And for that I will be using this service list once again and see the set pen service, what is the interface of the set pen service. So I can use the interface show for this set pen service, and when I see we get this uint8 RGB width off. So R, and it means because it is unsigned integer, 8-bit unsigned integer, so the values will be 0 to 255. If it is int 8 only, then values will be 1 to 8, 0 to 1 to 8 plus minus, because it is 8-bit, we are talking about 8-bit. So we can make a service request which make this tracing off. So that is what we did, and then we can also have this reset service. So I'll be using my command of reset rather than service. We'll just discuss, and then let it be pen is off, and now I will teleport this, and now you see that it is not tracing anything. So that is how we have to use the concept of setting the pen properties, where the colors, RGB, width and the status, whether you want to trace or not. So that is what we will be using. We will be teleporting from one place to another place to draw that, to trace that cycle correctly. And the third thing is the command velocity that will be doing at last when we will be moving this while tracing the circle. I want to draw this frame starting from here to here, then this, and handle, and then this. So it is very difficult that we keep on writing the terminal command, and then if something went wrong, then it is difficult to make it correct. So it is always better if you want to have a series of terminal command to create one script file, shell script, and that will be easier for us, and we can directly write everything in that shell script, and then only we can write a shell script having all the commands together, and that will help us in tracing or running or executing all shell script together. And for that, I have done is, in the src folder of our ROS2 workspace, I have created another folder with the name of CLI, that is command line interface, and then it's user defined name. Basically, it is not necessary that you write CLI. I use CLI, and then we can write the commands in this. So if I use this, for example, for plotting, moving turtle from one place to another place, and then with changing color and all that. So that is what basically I have created one script file for the frame. In the set pen service, I make this off as true so that it will not trace. And then I am moving this from center to 3.5 to 6, and then I am once it took its start position of the column, then I make it false, and then again I moved the turtle from the column this position to this position, and that is what is happening here. And then again I have to change the color, and that is why this is the again set pen service to change the color as desired. And then I can move it from uh, this position 3 to 5 5, and then to 8 3. I have to change the mode of that file so that it become executable, and it is there in src folder. I am right now here in ROS workspace, then src folder, then CLI folder, and then this name of the file, that is cycle underscore frame underscore 2.sh. So extension of these files will be sh. Let me have ls dash al, and the file name is srccli cycle underscore frame underscore 2.sh. So it will give me that everywhere it is user, group, and admin. So it is all executable. So that is how we can run this. So now to run this file, I have to use this command, that dash srccli, and then again cycle underscore frame underscore 2.sh. So if I use this, so now it will be tracing the frame. So similarly, once I have traced the frame, now I can trace the handle as well. So for handle, I have to move this turtle here, and then I will be tracing it to other place. The coordinates are given here. So for handle 3.7 to 6.1, 3.3 to 5.5. So for handle, the script is like this. So first of all, we have to make it off, that should not trace anything. So that is why off is true. Then 3.7, 6.1, and it will move to 3.3 and 5.9. So after making the off as false and then changing the color as desired. So now I can run this command, that is the frame is done. So it is handle. So I can use handle.sh. So once I use handle.sh, it will be plotting tracing handle.sh, and similarly we can go for a seat. So seat is slightly longer file because there are many things, color is changing. So first of all, certainly when we are moving, before that we have to set this off as true so that no trace is marked, and then we will be moving this to 5.5, and 5.5 is nothing but this is the 5.5, and then we have to off as false so that it start tracing it. The color is also pinkish, so that is why the arguments R and B RGB are like this. Then we will be moving teleport absolute to 6.5, then again making the change in the color, and then again moving it to 6 to 5.4, change in color, then moving it to 5.4, and again the change in color, and then moving it to 5.5, that coming back. So let me run this command. So certainly after this, if you are creating your own, so first of all you have to use chmod to make it executable. So now we can execute this seat. So this is how the seat will be traced by the turtle, all different color, and it's all because of the commands that we have added here in our script. So these commands are all set pan service and the teleport absolute. So now the another that is very important interesting part is tracing the circle, and this tracing a circle is nothing but we have to publish command on this command velocity topic cmd underscore vel, that otherwise we have used tally of keys. If you remember in our last practice session of CLI tools, that is we were publishing the command on the topic cmd underscore velocity, and that was using twist message type. So if I use this ROS2 command to publish this and make a 1 unit circle, then this is the commonly used command that we use, that X and Z, and this will start basically directly publishing, and it will keep on rotating, and there is no end to this turtle unless until we define something that it has to rotate once. So we can either give this command once using one argument, otherwise it will keep on rotating. So let us cancel this and then again use another that argument of once, and let me change the position before we start this. So let us move this turtle somewhere else using this teleport, and let me copy these two commands together so that it does not trace when it moves from one place to another. So let me run these two commands. So now it has moved, turtle has moved to this place, and now I'll use this once command for the publishing on topic CMD velocity. So if I use this, then you will see that we have not basically started that pen again. So I have to make it false. So let me make it false so that it traces something, and then again use the command. So if I use this once command, that once argument that I have added here, so it is basically publishing only once. So once publishing means it by default it is valid for 1 second. So what is here? So another way of another argument that we can use is the hertz, that what is the frequency of publishing, but that will not solve our problem of handling only one particular circle. So how we can do that? We can do that by only changing this speed, angular and linear speed. So if I change linear speed such that this speed, because if you use once, it means it will publish only once, but if and once, and that is for 1 second, and if I make the velocity such that within 1 second it completes one particular circle. So for that the command velocity, linear velocity, should be equal to 2 pi radian per second. So that is what is there. So I will make it 6.28, and when I change this linear velocity, I have to change the angular velocity so that the radius of the circle remains 1. Otherwise it, because we know that V is equal to omega r, and then the r is the ratio of V by omega. So if I make it 6.28, though it won't matter much, but it's only the matter of radius. So but if it is not 1 unit, then again the time period will be different. So I have to make it 1, radius 1, so that in 6.28 second unit per second, and for 1 second it travels 6.2 units. So if I now make it, so you can see that it is tracing approximately 1, but that is not a perfect solution. We cannot make it everywhere. You cannot calculate that precisely every time. If radius changes, the angular velocity and linear velocity has to be changed. So that is the challenge in this, but certainly we can, for now only, we can use this logic that we have used here. So I have moved this by switching off the pen, and then teleported it, and then again this switched on the pen, and then push this command velocity topic, some velocity, and angular velocity. So the same thing I did for the next wheel. So let me use first this reset, so that I reset everything, and I'll just basically showing you how this cycle wheel are being traced. So the name of the script is cycle wheels .sh. So if I run this, then you can see that it moves teleported, traced one cycle very fast because the linear and angular speed are 6.28. Then it's waiting for some time, and then it is putting drawing or tracing the another side wheel. So likewise, when we move everything, I have created one script file, that is cycle.sh. All scripts, all terminal command I have added here, and now let me use this reset first and use this particular shell command or shell script. So that is, the name is cycle.sh. Then this will be plotting this complete cycle. So that is all for this particular tutorial. You can download this complete script from my GitHub page, that is VK Jadhav. The link is given in the description below. So in the next session, we will be understanding how to create the nodes in ROS2, that is the power of this ROS2, what is its structure, and how can we write the subscriber and publisher, service client and service server. So that's all for this particular session. If you find this tutorial helpful, do not forget to like this video and subscribe for more tutorials. Until next time, happy learning. Thank you.